Good morning, everybody. This is a live emergency severe weather briefing as it looks like we're going to have to reactivate storm chase mode. This time coming up over southeastern Kansas into northeast Oklahoma tomorrow late afternoon and evening. Looks like the relatively late initiation of supercell storms, probably about 4 to 5 p.m., probably near Parsons, Kansas, southeastern portion of the state. And then it's going to dive off to the south-southeast into northeastern Oklahoma, Miami, Veneta area. The former world's largest McDonald's could be impacted by these storms. And the main threat is going to be guerrilla hail with this target area, but there definitely is a threat of an isolated tornado as well. The mid-60s dew points definitely have my attention. Usually these rare northwest flow events relatively early in the season with a bunch of cold air aloft oftentimes do go pretty big, and that's why I'm going to be flying in for this event. I am getting a Dominator rental car on this one. I do have to drop off the Dominator Fore at the shop today before I head out. That's just a necessity because the vehicle has been beaten down. Just about everything needs to be replaced on Dominator Fore. Just about everything is damaged, and I'm going to get that fixed and then use a Dominator rental car. Here you can see the moisture axis, and look at these mid-60s dew points that are in place ahead of the front. This is a northwest flow event, a supercell storm. Convective allowing models initiate at least a couple of isolated supercell storms in the southeast portion of the state. Updraft helicity tracks by the HRRR, south-southeast bombers just diving southeast within that warm sector, likely wind-driven baseball to softball-sized hail. Big, chunky hooks as well will be on radar, and there is a threat of an isolated tornado because of the dew points. Just because 65 dew points this time of year with the northwesterly flow event, oftentimes they do go big. And the HRRR, which is notorious for overmixing dew points across the southern plains and especially the high plains, still has those mid-60s dew points, and that's why I think it is going to be quite substantial. And this is going to be the first of 4 days in a row of storm chasing. Looks like the northwest flow event on Thursday, and then look at this mega trough ejection that takes over the western U.S. There you can see it start to arrive in the western U.S. there, big southwesterly flow. And that's because it's a year 2 La Nina, warm NPO or North Pacific oscillation across the North Pacific, as we've talked about all fall, basically starting late last summer through the fall into the winter time. And that definitely encourages the formation of a western U.S. trough, a ridge off the southeastern U.S. The ridge off the southeastern U.S. helps to maintain a gentle southerly flow on the west side, and that just keeps that moisture, the moisture supply, the rocket fuel for these troughs in the Gulf of Mexico energized with that high pressure off the coast. The squeeze play in between them, that's why you get those big low-level jets. You get the squeeze play in between the high off the southeastern U.S. and the mega trough ejection. Look at that trough ejection ski jump configuration nosing right up into Nebraska. And I have, of course, seen the comparisons of this event with Manchester as well. Manchester 2003, that was one of the biggest tornado intercepts I had, and it happened relatively early in my storm chasing career as well. Started getting everything set up off to the races in 2003. I intercepted a bunch of tornadoes before that in 2002, 2001, 2099, and 98. Nearly got a tornado in 97 as well. But really, that Manchester event, selling DVDs, is really what got me started storm chasing. So this is the 850 forecast for 22Z on Wednesday. That's about 5 p.m., 22Z, and you can see the western edge of the low-level jet there, southwesterly low-level jet right ahead of those storms. And imagine a storm diving into that low-level jet. So it's moving south-southeast, moving right into that with nearly a 90-degree angle into the low-level jet that is off to the southwest. Upper-level winds driving that storm motion down. So really, when you have a southerly component to the storm motion, you kind of have to add the magnitude of the low-level jet a bit in a storm relative sense. So you really 20 knots out here across southeastern Kansas, probably more than sufficient to generate a tornado threat. Looking at the 0 to 1 kilometer storm relative helicity, it's marginal, but with a storm that's going to be diving down into this environment, notice how it increases with time down into northeastern Oklahoma. You start to get those 0 to 1 kilometer SRH meter squared per second squared values greater than about 150 down there where you see the yellow. Storms initiate first at about 5 p.m. right near that elbow in the front. little bit of an elbow there, even a pseudo dry line structure. You can see the southwesterly winds to the west of the moisture axis, due southerly winds just to the east of the moisture axis, and these are going to dive into that moisture across northeastern Oklahoma, certainly. And we could look at the 0 to 1 kilometer EHIs. Let's see where the surface space instability co-locates with that low-level shear. And you can certainly see the pipe of shear that these storms are going to be moving into. It's also oriented roughly parallel to the storm motion. So the storms are going to fire near that elbow and move south-southeast into that environment through southeastern Kansas, eventually into northeastern Oklahoma. And basically, the instability axis being parallel to the storm motion vector is going to give these storms a long residence time within that elongated instability axis as they move from southeastern Kansas into northeastern Oklahoma. That is 0 to 1 kilometer EHI, or Energy Helicity Index, that you're seeing right here. And the last update, well, let's look at a quick forecast sounding here while we have this popped up. And I want to show you what a textbook northwesterly flow hodograph looks like for tornado potential. Here you can see the hodograph curve looping all the way around like that. Classic sickle-shaped hodograph curve, storm motion vector off to the south-southeast. Can't even see it on there. But your storm motion vector is basically due east at about 15, but I do expect them to dive a little bit further south. I bet you'll probably be talking about 20 knots due southeasterly storm motion, especially for those storms that are turning right movers. A lot of times these northwesterly flow events also will end up deviating a lot more than what the bunkers storm motion will indicate. So I wouldn't be surprised if these do bomb off to the southeast at about 10 knots, but relatively slow storm motions. A lot of storm relative inflow within the lowest 3 kilometers. You also get some ventilation aloft by the near due westerly, even northwesterly as you go aloft into the atmosphere, driving those storm motions a little bit further right. But look at the elevated mix layer just above the ground. Very steep low-level lapse rates. Surface-based parcels easily break the cap, and you're talking surface space instability of about 2,300 joules per kilogram. 0 to 1 kilometer SRH, close to 200, so not as marginal as you might think with the southwesterly low-level jet at 30 knots, and you have a lot of directional shear within the instability axis. Due southerly low-level winds, southwesterly 1 kilometer wind, westerly winds up to 6 kilometers, and then you get those northwesterlies up in the upper troposphere, increasing to about 60 knots, creating plenty of bulk shear, certainly greater than about 40 to 50 knots of 0 to 6 kilometer bulk shear, more than sufficient to generate supercell structures. And of course, the 0 to 1 kilometer storm relative helicity is proportional to the area contained by the hodograph curve and the storm motion vector. And we've got a critical angle that's actually greater than 90 degrees. So that storm motion, as it dives southeast, should be moving roughly parallel to the instability axis and the shear axis, which you can see very clearly extending from southeastern Oklahoma or northeastern Oklahoma, southeastern Kansas. There's initiation at 5 p.m. near Chanute, just near the Parsons-Chanute area, southeastern Kansas. Also initiation of elevated storms near the Kansas City area by about 5 p.m. And look at that thing blossom by 6 p.m. southeastern Kansas to the west of Pittman, west of Girard, Pittsburgh, definitely west of Girard as well. Baxter Springs area, a little closer to the Missouri border. There's Osage County off to the west. So this one is heading toward Miami in northeastern Oklahoma. Looks like a bubbler tries to form, though, in Osage County at 6 p.m. And at 7 p.m., that storm is bombing down to the south, getting closer to the Oklahoma-Kansas border. That's at 7 p.m. 8 p.m., it starts to move into the Miami area. Probably incredible supercell structures, motherships out there, giant windshield shattering hail as well, and also a threat of an isolated tornado as that bombs off to the south. Let's look at the low-level jet. And it is hanging on. Look at that 30 knots, nosing up into northeastern Oklahoma as that storm is moving into that environment right along the 850 front. And look at that acceleration of the flow into northeast Oklahoma. Let's take a quick gander at what that hodograph looks like. And even though you do get an abundance of a capping inversion that develops a little bit later on, you have massive elongation of the hodograph with time between 5 p.m. And at the time of this model, which is about 8 p.m., a large curved hodograph, 0 to 1 kilometer SRH in excess of 400. You can see the area enclosed within the hodograph curve and the storm motion vector, much larger as well. Southwesterly low-level jet pushing 40 knots within that environment. And it's likely enhanced with the inflow into that supercell storm that's going to be diving into northeastern Oklahoma. But certainly can't ignore the favorable environment. And just for the hell of it, let's look at the STP significant tornado parameter. Right where we were looking at that forecast sounding, you can see everything coming together across northeastern Oklahoma. That's at 8 p.m. Far northeastern Oklahoma, southeastern Kansas as well. And that is a classic strongly sheared instability axis right there, especially for a south-southeasterly mover. And notice how you have a lot less in the way of that vertical motion in the mid-levels of the atmosphere on this sounding. You don't have those bars sticking up. I think that last sounding that we were looking at was actually inside of the supercell storm, or at least the inflow of that supercell storm, a bit of a tainted forecast photograph. But look at how these surface temperatures cool as you get closer to 8 p.m. across northeastern Oklahoma. So even though the wind shear blows up, you do get the development of a stout nocturnal inversion. See how those surface temperatures nose down, the dew points nose down, and then the temperatures warm up with height. That's a classic inversion, capping inversion, exacerbated by the cooling of the surface temperatures after peak heating and just after sunset. But a very textbook photograph for isolated tornado potential for a south-southeasterly mover at about 20 knots, southeasterly mover, carving out a ton of 0 to 1 kilometer shear in excess of 300. But really the loss of surface access to the surface-based moisture is going to shut down that tornado threat as these storms bomb into that environment. The tornado threat I don't see continuing too much after sunset. And it does look like the greatest wind shear is just east of this instability axis, but right along the eastern gradient of the instability is where you get the greatest low-level wind shear, right in the heart of the instability axis. It tails off just a little bit, but look at that, those southwesterly winds at about 35 knots feeding into that environment. 850 trough diving off to the south. Basically a northwest flow event here, peeling off, forming on this ribbon, a bit of a jet streak here that arrives across southeastern Kansas right in time for peak heating. That's 4 p.m., 5 p.m. There's the arrival of that jet that initiates those storms over southeastern Kansas by about 5 p.m. and then continues to move off to the southeast. Just for the fun of it, let's look at the updraft helicity tracks. I was joking around the other day that I'm just going to be using this to forecast from here on out. But there you can see the updraft helicity tracks moving southeast, southeastern Kansas, and pushing into far northeastern Oklahoma. But it does look like more of a southeastern Kansas event now. I know some of the convective allowing models were initiating storms even down into the Oklahoma City area by peak heating. That is one notable shift, is that now the convective allowing models are shifting more towards southeastern Kansas and northeastern Oklahoma with those helicity tracks. A couple of supercells forming within that environment, certainly. I'm going to be chasing this event, of course. I do think that the threat of tornadoes is real, especially the threat of guerrilla hail, though. Just can't miss out on the threat, potential threat for guerrilla hail. Might have to keep the rental car out of it a little bit because of the changing rental car policies a bit these days, but certainly will be in position to intercept the tornado. So now let's focus on Thursday and especially Friday. Friday looks like the more substantial severe weather event. I know that the 84-hour NAM is showing a quite favorable environment across northern Nebraska, as well as into southern South Dakota. That's going to be the 84-hour NAM. Let's jump straight to the chase. Look at this Sandhills monster. This is the forecast for April 22nd. That's going to be Friday, April 22nd. Pretty big warm front. Lifts all the way up to the Nebraska-South Dakota border. There is the 84-hour NAM showing that very favorable environment. Warm frontal zone lives very close to the South Dakota-Nebraska border. And a lot of the analogs for this related it to the June 24, 2003 Manchester tornado. And I know that many of you have seen that tornado video as well. Let me see if I can find it really quick and I can play it for you on here. But Manchester, June 24, 2003 was a massive wedge tornado that we intercepted over southeastern South Dakota. The main severe weather risk that day was back into Nebraska. I believe there was even a moderate risk back into Nebraska. A majority of storm chasers targeted Nebraska, even southwestern Nebraska that day. Dew points completely mixed out across central and southern Nebraska. And the warm front was really the only play on the Manchester day. Up in Manchester, South Dakota, an F4 happened. Basically turned Manchester into a ghost town. And that same tornado is the one that Tim Samaras deployed his turtle probes on and measured the world record pressure fall at the surface using his canonical probe, basically modeling out the differential pressure distribution across the surface of the probe to remove the impacts from wind. But a lot of storm chasers targeted central and southwestern Nebraska on that day. But boy, do the sandhills look favorable. Look at that directional shear. Southeasterlies at the surface, increasing to about 50 knots just above the ground. Massive hodograph as well. Let me scroll this up a little bit so that you can see the directional shear. Right here, you can see those southeasterly surface winds. You can also see the southwesterly low-level jet in excess of 50 knots. And then you go over to a southwesterly mid-tropospheric wind, upper tropospheric winds about 50 knots. This is all ahead of a megatroph. And look at the dew points. Mid-60s, no problem up along the warm front, at least according to the NAM. I know the NAM model hasn't been doing too incredibly well this season, but still we're going to latch on to the NAM because look at that hodograph, and it also shows the potential ceiling of this event. You can see a lot of easterlies in the low levels of the hodograph. Anything over in this quadrant represents those southeasterly winds at the low levels. Classic central, even high plains type of a shear profile. Southeasterly winds all the way up, and then finally you get those southwesterlies in the low-level jet, increasing to about 50 knots, and then your upper-level winds ventilating the updraft, outflow, evacuating the hail aloft as well, keeping those updrafts clean and relatively rain-free. And here's your storm motion, southwest to northeast at about 30 knots. That's your storm motion vector. A vector is a magnitude and a direction. And southwest to the northeast at about 30 knots. This is your surface wind, a southeasterly wind at about 20 knots. This is your 1 kilometer wind blowing up to close to 50 knots, almost a due southerly low-level jet. And because of that combination of directional shear and speed shear, that's when you get these massive Great Plains hodographs. That's why Tornado Alley is defined as such. That's also likely why you get some of the most destructive, powerful tornadoes anywhere on the planet in Tornado Alley. It's also because they're not moving quite as fast as the tornadoes in the Mid-South that are moving much faster over any given point on the ground. So the residence times of those violent winds, those violent tornadic winds, are a little bit less over the same area. But wow, look at that massive hodograph, everybody. Burn that image into your head. That's a textbook hodograph, and you're pulling in close to a 90-degree critical angle. The critical angle is the angle that, well, the storm motion, the tip of the storm motion vector, you draw a vector all the way back to the base of the 0 to 1 kilometer shear vector. And if that makes a 90-degree angle, then you're pulling in pure streamwise vorticity at the surface. Big storm relative inflow up in this portion of the hodograph as well. Boy, is that a nasty hodograph right there. Let's take a look at the low-level jet. It's got to be huge. They're 850 low, classic over northeastern Colorado into the Nebraska Panhandle. This is normally a setup that you would see late May, maybe into June when the northern plains get active, but this year is a weird year, let me tell you. We were even chasing Central Plains in the middle of December with that mega record-breaking outbreak across the Central Plains. Here's your huge trough, ski jump configuration. Textbook ski jump trough ejection. Let me push this off to the right a little bit. And there is your ski jump. Classic ski jump configuration to the trough. Imagine a ski jumper just launching off the end of that. That's the nose of the jet. And we say a ski jump because usually at the nose of the jet right here, that's where things come together. You get the strongest low-level jet right there. You have the left exit of the jet streak creating lift, leading to runaway low-level cyclogenesis. Triple points often set up in that location, and you kind of get the nose of the instability axis that also launches up to the nose. So that's why noses are quite favorable for tornadoes, whether it be the nose of the upper level jet, the ski jump configuration punching into the Central Plains, whether it be the nose of the low-level jet punching right up into the nose of the mid-level jet, or whether right at the nose is where you get the triple point formation, the merger of the three fronts, the warm front, cold front, dry line, with a rapid cyclogenesis across the western plains. But these ski jumps are usually textbook. Usually when you get an open wave like this punching all the way into Iowa, that's the time when you want to play the warm front out, way out in front a little bit, just like April 12th. I should have known that. We were doing a lot of meet and greets after driving all night up there into western Iowa. Didn't get a chance to really look at detailed satellite imagery or any data, and we ended up missing that storm that fired on the double dryline bulge. In fairness, I didn't think that the double dryline structure being indicated by the HRRR was going to happen. I banked on more of a clean arc ejecting from eastern Nebraska to northwestern Iowa, the scenario that was being depicted by the 3-kilometer NAM. But boy, the HRRR has been on fire. Should have played a little bit further east. Even if you're just working the numbers game, it makes sense staying off to the east and keeping all storms in play that are going to be moving from southwest to northeast and interacting with the warm frontal zone. In this case, though, the upper level trough is just a little bit slower. The heart of the trough located near Yellowstone National Park, and then your strong flow right around the base of the trough, nosing right into the central plain. So this is definitely a nasty configuration, kinematically, big mega trough. And because of that warm NPO, year 2 La Nina, you have a large-scale trough that forms dominating the western U.S. You also have a large-scale ridge dominating the southeastern U.S. The squeeze play in between these two features is why you get a very large-scale southerly low-level jet. And that's really the key for tornadoes, is to have a strong a wind just above the ground, about 1 kilometer or 2 above the ground. The exception being in the high plains, where you often get easterly winds all the way up to about 2 to 3 kilometers before flipping around to modest westerlies. But this is the ski jump configuration that is going to be nosing into the region on Friday. So Friday looks like a big chase, probably across Nebraska into southern South Dakota. If the Manchester event, if we can take anything from that, it would say just hit that warm front, work the warm frontal zone. Dew points are probably going to mix out off to the south of the warm front. Surface winds will probably go to a westerly direction. But if you can work that warm frontal zone on Friday, northern Nebraska into southern South Dakota, probably going to be one of those mega wedges, big time tornadoes up there as well. Potential tornado factory happening up there. Thursday looks like a sleeper day, northwest Oklahoma, southwestern Kansas. You know how that can go sometimes. Southwest Kansas into northwestern Oklahoma, sometimes that can also go big. That's going to be the day before the day on Thursday. Sometimes those days end up going the biggest. But this is just one model showing you the 0 to 1 kilometer EHIs just blowing up across the Nebraska sandhills, nosing into far southern South Dakota as well, south central, southeastern South Dakota. There's your warm frontal zone. Maybe you end up playing way off to the east and just stay in Sioux City all day, banking for a renegade that's going to move across the warm frontal zone way to the east. Maybe you play the little bit of a bulge into the southeastern portion of the sandhills, or maybe you play the wraparound all the way up across the northern Nebraska sandhills. I know that my friend Dan Fitz is probably excited about this setup. His storm season definitely activating very early. Looking throughout that east to west oriented belt, and pretty much all you see are favorable hodographs. Massive sickle-shaped hodographs, in excess of 300 0 to 1 kilometer shear contained within the hodograph, 75 over 65, 10-degree temperature dew point spreads as well, big cape, just your classic big-time severe weather event. And that's going to be setting up across northern Nebraska, far southern South Dakota. Here's the GFS. The 12Z GFS is a little bit further north. I do think that that gives us a greater shot at the cap breaking. GFS definitely looks like southeastern South Dakota, and I bet it's just going to set up in southeastern South Dakota a little bit further north than the NAM models are indicating. What tarnation? Boy, it looks like Mitchell, South Dakota. Clearly the GFS looks nasty on Friday. That's about peak heating, 21Z, 0Z, excuse me. Look at that 850 low. A little bit further northeast over southwest South Dakota, but 50 knots nosing into the southeastern portion of the state, northern Nebraska as well, setting the stage for a potentially dangerous severe weather day. Let's see what the dew points are showing. Wow, mid-60s dew points all along that warm frontal zone. And if Manchester is any indication, then this whole warm frontal zone, even north of the actual wind shift, would destabilize. So the entire area within this belt of surface easterlies will then destabilize. You'll get heating of the day that will commence. And look at those temperatures. Even north of the actual wind shift, temperatures are in the upper 70s along that zone, mixing out just a little bit into southern South Dakota. Look at that, 86 over 47, 40-degree temperature dew point spread. So what you're seeing here is runaway mixing, southern South Dakota, and the mixing effect is when you have a dry adiabatic profile or relatively skinny moisture. You're basically averaging out the dew points from the surface all the way up as far as those dry adiabatic lapse rates run, 1 to 2 kilometers, sometimes even further up than that. And you're pulling the dry air down, you're bringing the moisture northward and just washing it out, averaging it between that 2-kilometer layer. And that's why the surface dew points will decrease, cloud bases increase. But you aren't allowed to mix to the north of the wind shift, north of the warm front where you get those easterly winds. Mixing is definitely not as prominent. But southeastern South Dakota, that would be Sioux Falls all the way back west toward Mitchell. Even the wraparound could go nuts as well. But that's just the GFS model, which I know there's a lot of warm 850 temperatures out there as well. Look at how warm those are. And that could prevent initiation. Wonder if it's going to be a lot like that June 6th day where the only tornado you had was right underneath the core of the 850 low and everything else was capped. That was June 6th, like 2008 or 9. Saw a tornado out there across southwestern South Dakota. That could certainly happen as well. But we'll just have to see. You know, we'll argue and debate and everything and discuss. Is the cap going to be an issue? Should I fly out there? Shouldn't I fly out there? But that's why I'm getting out there early. You know, look at these favorable photographs there. You can see all the hook-shaped, sickle-shaped photographs all the way around that wraparound zone of surface-based instability. Pretty good photographs as well across the far northeastern portion of Nebraska. But really northeast Nebraska, especially southeastern South Dakota, looks to be the most favorable zone. Very warm 850 temperatures overspreading that area. There is going to be a risk that initiation may or may not happen at all, but I do think this warm frontal zone, it's a South Dakota warm frontal zone. It's early in the season, but look at all this mixing that happens. This is the European model, by the way, which is also showing these quite favorable photographs across eastern South Dakota, south central South Dakota as well, and then runaway mixing off to the south across central and eastern Nebraska for this event. But definitely a large trough ejection, but I wouldn't be surprised if the big event is going to be tomorrow as well, or even Thursday. Let's see what the Storm Prediction Center has. The day 2 event, I think the new day 2 is out. Still a 2% tornado risk, southeastern Kansas. Surprised they didn't upgrade. Oh, I guess this isn't coming. The new day 2 is not out yet. That's going to come out at 12:30. But the other day 1. And let's not forget about Western Oregon when that system comes in on Wednesday. This is going to be tomorrow. So this is definitely a risk that we want to take a look at as well. Western Oregon, probably going to be some low top storms that are coming into the Pacific Northwest. So let's take a look at that as well. We'll go back to the 12ZH-RRR, 36-hour forecast. Let's go back to about 21Z. Pretty good low-level jet nosing into Western Oregon. Let me straighten this out again. So, wow. Look at that into Western Oregon. That's your 1 kilometer wind, 850s, 30, 40 knots. moving into western Oregon. You'll need to pull in just a little bit of moisture from the Pacific as well to generate some of that instability, but a lot of cold air aloft as well. You could pull in a little bit of that Pacific moisture and maybe even get a 50 dew point, but at least upper 40s. And there is a ton of cold air aloft as well. Convective allowing model, 3-kilometer NAM shows that a little bit slightly greater moisture, some upper 40s right along the coastline. A lot of cold air at 700 coming in over top. Those upper 40s dew points, temperatures into the upper 40s as well. Very cold at 700, so that's passing over at surface space, and that's going to generate some low-level CAPE as well that's available to these storms. Your traditional indices even pick up a little bit on that environment, that favorable shear environment into the Pacific Northwest. And you're going to see these bubblers come ashore. Western Oregon, bubblers, Northwest Oregon. Each of these will probably have water spouts. Probably a couple different rounds of the bubblers once that cold air arrives. Looks even at early afternoon. Could see some bubblers moving onshore. Look at these. So all day in western Washington, as that cold air is filtering over top, the relatively warm temperatures, you got about 50 degree surface temperatures, upper 40s, dew points mid to upper 40s at the low levels, very cold temperatures just above the ground. And that's why the Storm Prediction Center has a 2% tornado threat in place across western Oregon. Look at this low-level shear. Big-time low-level shear. And apparently this is also on the 50-year anniversary of a big tornado that happened across western Oregon. Shear maximizes in western Oregon late morning. And then the cold pocket of air arrives just behind that. But look at that low-level jet there, 50, 60, 70 knots late morning across the coastline of Oregon. A very windy day as well out there. Tomorrow, late morning into the early afternoon. And then you start to get a weakening of that. A weakening of the low-level jet a little bit, but then that cold pocket of air aloft continues to filter overhead, generating a lot of instability, bubblers, isolated convection coming off the eastern Pacific. Meridional flow, about 60 knots in the mid-levels of the atmosphere out here. It looks like there's quite a bit of diffluence aloft as well, just ahead of that trough. So, oops, wrong model. Sorry. That's the morning. Look at that cold air coming in. Looks like starting at about midday is when that tornado threat is going to maximize, and you really get the cold pocket of air coming in off the Pacific. The low-level jet shifts to the east, and then you start to get that cellular convection coming in, and you do hang on to a stout low-level jet as well. 40 knots just streaming off the Pacific. So I do think that there is a decent threat of a tornado out there. Bubblers coming ashore across western Oregon. I know that's a pretty rare event out there, but it's happening. Look at these bubblers coming in behind. Might get a pretty sharp squall line associated with that low-level jet. Supercells moving ashore 1819Z. That's 11 a.m. Pacific. So this convective line comes in at about 18Z, 10, 11 a.m. late morning. Look at it come ashore, right coincident with that big low-level jet moving on off the Pacific. You've got 60 knots, 50 to 60 knots just ahead of that convective band that moves ashore into western Oregon. Wow. Right beneath, right at the leading edge of that cold pocket aloft too. And that comes ashore in western Oregon, upper 40s dew points, temperatures possibly near 50, very cold pocket of air aloft. And you're probably going to see some of those landfalling water spouts, even some tornadoes across western Oregon, 20Z. And then the cellular convection moves in back behind it, at least a couple rounds of this tornado potential. And the air aloft continues to filter in, gets colder and colder. Definitely could see some tornadoes as well, continuing all the way through at least the middle afternoon. And then it starts to subside. And then you get bands of squalls that move into southeastern Washington ahead of that system as well. So that's the severe weather synopsis, everybody. Thank you for joining me for this in-depth forecast model discussion. I'm going to be flying in tomorrow, renting a car, and then chasing southeastern Kansas into northeastern Oklahoma. Thursday looks like northwestern Oklahoma, southwestern Kansas, maybe some runaway mixing, and then heading up into southern South Dakota for the event on Friday, and then I'm coming back. But it's an exhausting tornado season so far, but keep in mind, I think eventually this really active severe weather season is suddenly going to shut off like a light switch. It's going to be a step function when it happens, and when it does happen, everything is going to shut off in a big way, and we're probably going to see the mega drought develop. But as long as that warm NPO is cranking in the Pacific, we're going to continue to get the encouragement of a western U.S. trough, a trough ridge pattern from west to east across the United States. There's the mega trough that's going to potentially lead to significant severe weather on Friday across northern Nebraska into southern South Dakota ahead of the ski jump that's nosing into the Central Plains. So you certainly could get a pretty big severe weather day, northern Nebraska, southern South Dakota, just ahead of that ski jump configuration. And that's April 22nd. So really quick, before I sign off, I'm going to try to go for about a 10-mile run today. Try to squeeze out blood clots a little bit. This is on Sunday, another little trough. And then there's the next system setting its sights toward the end of April. It could be quite active. Yet another encouragement of the western U.S. trough pattern. Or just too far out. But notice how the trough is starting to get a little bit more diffuse looking. It's not that powerful, consolidated peak polar front jet that we see during the winter into the earlier spring. But definitely we got to focus on the events right in front of us for 3 to 4 days in a row of storm chasing potential. And I will be live starting tomorrow, late afternoon, southeastern Kansas into northeastern Oklahoma, and then a pretty substantial severe weather event across southern South Dakota, possibly into northern Nebraska. Thank you, everybody, for joining me. Hit that subscriber button, notification bell. You guys know what to do.